Let's work on a few more attempts at graphing functions given the graph of a derivative. We're going to focus exclusively on the information about the derivative. So some things to notice on this example. We know that at -4 the derivative equals 0. So that's where we would expect our original function to have potentially a horizontal tangent. At -1 it's 0, and at 4 it is also 0. Now notice that before -4 our derivatives are negative, which means that the original function should be decreasing. Between -4 and -1 our derivative is positive, so our original function should be increasing. From -1 to 4 our derivative is negative again, so our function should be decreasing, and then after 4 it returns to positive, so we would expect this function to return to increasing. So using that information, and only that information, if we want to sketch a possible graph with our key values being where the changes occur. So it occurs at -4, at -1, and at +4. So initially our function should be decreasing. Right? So we have no idea where it would be at. We know it should be decreasing until it gets to -4. So, until it gets to -4. So we know it's decreasing, and then at -4 there should be a horizontal tangent. And now our function is going to begin to increase until it gets to -1. And we don't know exactly what it's doing, but we know it's just going to increase until there. And then it's going to change again and be decreasing. It's going to be decreasing until it at least gets to 4 again, doing something like that, and then our function will start to increase again. Alright, so we've got our features. Our function is decreasing, tangent is 0, increasing, tangent is 0, decreasing, tangent is 0, increasing. This is a sketch of a possible graph. Let's consider another example. So here we have the graph of a derivative. We've got some key values at -4 and +1 because that's where the derivative is 0. So that's where our function's slope should be 0, or there should be a horizontal tangent at -4 and +1. The function is negative before -4, so we would expect it to be decreasing. It's positive between -4 and +1, so it should be increasing on that interval, and it remains positive after 1, so it should flatten out and then continue to increase. So our function should decrease, flatten out, increase, flatten out, increase some more. So if we go again to sketch a graph relating what we know, with the important points being changes that occur at -4 and at +1. So our function should decrease until it gets to -4 and have a horizontal tangent there. Then it should increase until it gets to 1, where it will flatten out and have a horizontal tangent there, and then it will increase again. So here is a sketch of a possible graph of that. Let's look at another example. See if you can come up with a sketch of the graph yourself. So pause the video, see if you can sketch it yourself, and then come back and see what happens. So I can see in this graph that the only time that the values of the derivative, which this is, change is at 0. So at 0 is when the derivative equals 0, and that's where I would expect my original function to flatten out. Before 0, the derivative is negative, so my function should be decreasing, and after 0, the derivative is positive, so my function should be increasing. So So the sketch of the new function should decrease, flatten out, and then increase. So a basic sketch of what this might be is a function that at 0 will flatten out. We'll say it flattens out maybe here. And it will decrease into that and then increase out of that. It might be something like this. And that should make some sense. We've got a cubic and maybe a 4th degree polynomial. It's real basic. Final graph for this section. So again, here is a graph of a derivative. Pause the video and see if you can come up with the sketch yourself of the original function. And see how you did. So we know important points are -4 is when the derivative equals 0, and 3 is where the derivative equals 0. So my original function should flatten out there, should have a horizontal tangent. Before -4, my derivative is negative, so my original function should be decreasing. After -4, my derivative is positive until it gets to 3. So my original function should be increasing. After 3, it's negative, so I would expect it to be decreasing again. So my graph should be decreasing, increasing, and then decreasing again. So I go and try and make a sketch of this, with the important points of change being at -4 and 3. What I know is it should be decreasing into -4, where it will have a horizontal tangent. Then it will be increasing all the way until 3. So it's going to be increasing something like this. And then at 3 it's going to change, and my derivative, my original function, should be decreasing again. So it may look something like that. Again, this is a tricky idea. You're trying to connect a lot of new ideas to you, most likely, and you're having to reverse the connection. So the hardest part about this task is taking new concepts and applying them in a reverse kind of direction as well. Both tasks are challenging.